Hi, welcome. Today we're looking at probability tables and we're going to address the following two learning intentions: to define a two-way table as an alternative to a Venn diagram and to apply two-way tables to calculate combined event probabilities. And hopefully by the end of the mini quiz we will be able to apply two-way tables to model and calculate combined event probabilities. So what is a probability table? You might have seen this before. It's also known as a Cardan map, and what it does is it matches up an event with its complement. So the event A and its complement. And it's another visual representation, but it's very, very useful for when dealing with probabilities, because if we have the probability of A occurring and not A occurring, we can make some very, very quick calculations. So what we're going to do with this two-way table here is to put the information from this Venn diagram and transfer it and see how it is an alternative for a Venn diagram. We have these four regions here: A intersection not B, A intersection B, not A intersection B, and not A intersection not B. So what these are is A intersection not B. This is only A, so A only. Not A intersection B, B only. A intersection B, and not A and not B. So how do all of these fit onto here? Well, A intersection not B, where is A and not B? Not A and not B. A intersection B. And B intersection not A. So our last region then. Okay. Now what does all of this tell us? All of this is put together to say that these two are the probability of B, probability of B. These two put together gives us the probability of not B. And together must be 1. These two horizontally must give us the probability of A, and these two must give us the probability of not A. And once again, those two probabilities together, A and its complement, must add together to be 1, or 100%. We have a few formulas here to note. The first one, probability of A intersection B plus probability of A intersection not B is equal to the total probability of A. Jot that down in your notebook. And what we're going to do is provide you with a visual representation of what that looks like. So visually, the probability of if two events, A and B, their intersection is the middle region here. If we then add that with the intersection of A only, then together they give crescent moon plus an intersection. Put the pieces together, they give us A. These second two formulas to note. What was mentioned in the two-way table, that the probability of A and not A is equal to 1, and likewise B and not B is also equal to 1, or B and its complement. Visually, let's have a look at what that appears like in a Venn diagram. Probability of A. Then where's not A? Just this region here? Or also out here? The second one is a representation of not A. Putting those two together gives us the full Venn diagram, or 100%. And this can be said for B as well, and not B. we have the probability of not A intersection not B. So this region around the outside, which is neither of these two events. And we're saying that this can be calculated by taking 1, or 100% probability, minusing the union of A and B. So all of A taken with all of B. And this can also be written as probability of A union B complement. So 1 take away the probability of all of this, or written as probability of A union B complement.
I'll take you through an example of how we can use a probability table. In this example, we're given the events E and F. They give us the union, they give us the intersection, and they give us the complement of one of these events. So let's draw a two-way table. Draw a two-way table here on the side. And what our table is going to have is the event and its complement pairing off of each other. Event E and its complement, and event F and its complement as well. Now it's time to start filling in some of these values. We'll start, we don't know what the union is yet because that's a combination of multiple regions. So let's fill in the intersection of event E and F. The intersection will be where these rows and columns overlap, and that has a value of 0.15. What else? Well, I know that the complement of E is 0.55, and that'll go right down here at the bottom, 0.55. That's told us the probability of the complement of event E without being explicit about F or not F yet. So the total probability of not E is 0.55. What else? Okay, we know that all of the probabilities must add up to 1. And there's really no more to fill based on the information given in the question. So let's derive some of the other values. Okay, I know that this row should add up to 1. So in this box, we should have 0.45. This column should add up to the total, 0.15 plus 0.30. Then I need to use some information that's given in the question. The information given in the question is the fact that the union of E and F is 0.7. In other words, the union is E and F, F only, and E only, and we can calculate that. So we're calculating this box. It's the sum of 0.15 plus 0.3 plus this thing, F and not E, and that's going to be equal to our union, 0.7. Rearranging this around, we have 0.45 plus that intersection, which means that intersection should be 0.25. Okay, and with that box filled in, we can fill in the remainder. The remainder is going to be, so let's add across 0.4. Let's find the difference between 0.25 and 0.55, that'll be 0.3. Add across 0.60, and we can check our answer. The final column does add up to 1.
Can I just jump in there for a moment? You'll see that the table's now filled, and we can kind of do a very quick guess and check, a very quick confirmation that we haven't made any mistakes, which can happen. Now, you might have noticed that right from one of the very first entries we made, we could have answered part A. But it's important to make sure that we can fully complete the table before attempting any of the problems to make sure that we haven't made any mistakes along the way.
Now let's answer some of these questions. The probability of event E, given by our table, we'll just read down here, 0.45. The probability of event F will be here at the end of this row. That will be 0.4. The probability of the intersection between the complement of E and F, that would be this one in red that we found. That would be 0.25. And the probability of the union between the complement of E and F. Now we'll have a look at two ways to find this, but firstly, understand that we can figure out this based on our addition rule. Let's write our addition rule. The probability of the complement of E plus the probability of F, take away the intersection. We have all these values, so let's plug them in. E dash, it's not E, that's 0.4. F, got that right? No, I haven't. Let's try again. The probability of not E is given by this column, and the answer is 0.55. The probability of F, given by this row, at the end it says 0.4. And then we subtract the intersection between not E and F, which is here, 0.25. Let's evaluate this. We have 0.95, take away 0.25, and the answer is 0.7. The other way to have found this answer, which is the union between not E and F, keep in mind that not E would be these two regions, and F would be these regions. So to find the union from your table, you could have just added these numbers together, and it'll also be 0.7. Let's apply our probability table to answer another question. In a recent survey of senior citizens, it was found that 85% favoured giving greater powers of arrest to police, 60% favoured longer sentences for convicted persons, and 50% favoured both propositions. As you can see, there are multiple events going on, and we're looking at the relationship between those two events. Let's give some letters to describe those events. One is about giving greater powers. So let's use the letter P to represent giving greater powers. Which means P dash would mean not giving greater powers. We also have longer sentences, so let's give it a letter as well. Let L mean a longer sentence. Now we've got our two events, let's make up a two-way table. 1, 2, 3. 1, 2, 3. Remember, we need to place the complementary events next to each other on this table. We've got P for greater powers and P dash for not greater powers. L for longer sentence and L dash for not longer sentence. Let's see if we can fill in some numbers. 85% favoured giving greater powers, which means under this P column here, we should have 85%. What else? 60% favoured longer sentences, which would be this row. Anything else? And lastly, 50% favoured both propositions. So both greater powers and longer sentence. That would be 50%. There's also one more thing. If we add up all the senior citizens in total, we should have 100% of them. So let's add that in at the end. Now we can start populating our two-way table. This column should add up to 85%, so this would be 35%. The row adds up to 60%, which means 10% here. What else? Here, 15%. Here, 5%. And then downwards, it should add up to 100%. And we can check our answer across 35 and 5 also make 40%. Just a quick check to make sure these numbers are right. Okay, let's answer question A. What percentage favoured at least one of the two propositions? Favouring at least one of the two means we're finding the union between greater powers and longer sentence. There's a few ways to do this. Let's answer question A. The probability of greater powers in union with longer sentence. One way to do it is through the addition rule. So let's do that first before we look at our table. The addition rule would be the union being equal to the sum of P and L, and we subtract the intersection. That would be P intersect L. Now we can fill in some numbers. P is 85%. L is 60%. In fact, both of them were given in the question. And the intersection was 50%. So we subtract that. And the answer to this would be 85 plus 60, that's 145. Take away 50, that would be 95%. So 95% of senior citizens favour at least one of the two propositions. The other way we can work that out is remembering that the union is represented by these regions that I'll place red dots in. So if you add those up, you also get 95%. Let's answer question B. Question B asks, what percentage favoured neither proposition? So in that case, the question that's being asked of us is neither P nor L. And we know that to be this box that I've placed a star in. Neither P nor L. So from our table, we can answer the question that 5% favoured neither proposition. We've come to the conclusion of this lesson, which was on probability tables. Our lesson was to define a probability table as an alternative to a Venn diagram, and also to apply two-way tables to calculate combined event probabilities. Now that we're through the lesson, take some time to complete the style quiz questions and check that you've met the success criteria, which is can apply two-way tables to model and calculate combined event probabilities.